Hello, this is Professor Ratajczyk, and in this third video for our course, I'm going to look at how to do price elasticity of demand by using the midpoint method for the purchase of a video game. Okay? So again, oftentimes companies study price elasticity by introducing a new product and then seeing how sales go for the next 3 months or a year or a certain time period. Then they look at lowering the price or raising the price and seeing what they can learn about the demand after that. So in effect, they're using price elasticity, trying to determine the raising of the price, lowering of the price, does that have any impact on the number of customers that are buying the product, the frequency, the behavior in general. Okay? So we're going to work through price elasticity of demand here, and we're going to use the midpoint method. If you remember what the midpoint method is, it is the point between the two numbers, so the new value and the old value. Whether we're talking about price or we're talking about demand, there's that mid-level or midpoint, if you will, there. Oftentimes, we think of it as the average, right? If I've got a price of $10 and a price of $5, if I take the average of those two numbers, I'll have 7.5. Well, that's exactly the midpoint between those two numbers is the average. Okay? So it's very simple to calculate midpoint. The problem is remembering all of the steps. So I'm going to show you the steps here before we begin on how to calculate price elasticity of demand and evaluate it. Okay? So just take a look for a moment before we begin with the math. Okay, so step one, we're going to identify the midpoint for pricing. Step two, we're going to evaluate the midpoint for quantity demanded. Step three, we're going to calculate the percent change in the price using the midpoint that we've done in step one. Step four, we're going to find the percent change in demand based on what we've found for the midpoint in step two. Once that's all done, we get the fifth step, where we can finally do the price elasticity of demand calculation. And remember, that's quantity demanded on top of price. And the reason for that is we want to know what the change in price does to quantity. We're studying quantity because selling units is what's important here. So we want to know, are we selling 50,000 units, 75,000, 90,000, based on a price change? Okay, what is the actual change in quantity demanded? So that's why it's on top. Finally, the sixth step is the evaluation. So you do the math. You get a 1.58. Okay, that's step 5's result. Step 6, you need to explain what a 1.58 means. Is it price elastic? Is it price inelastic? But go a step further than that and explain, what does that mean? If it's price elastic, there's a lot of stretch. There's a lot of stretch out there in the quantity demanded. We would call that buyer sensitivity. If there is an inelastic, so it's less than 1 as a result, so a 0.92, which is pretty close, but a 0.05, it's not a lot of sensitivity. That could be like the oil market or a certain product out there that people buy regardless of the price because they need it. It's a necessity, like insulin for diabetic people, right? So let's begin looking at the math here. We're going to do step 1, which again is the midpoint for price, and then step 2, midpoint for demand. Then we're going to find the percent changes between them and go from there. I will explain each step here, even though I'm using Microsoft Excel. I use Microsoft Excel because it's a nice, clean way. But if you listen to what I'm doing, you'll be able to interpret the formulas and the steps involved there. Okay, so the first step we're going to do is we're going to find the midpoint between these two numbers here. Now, I could go 61, 44, 62, 43, and keep going until I find a number where they're next to each other, right? but the average works the same way. So I'm not going to use the average function in Excel, but I'm just going to show you the math of what you would do on your assignment or on the exam. You would take the 60 plus 45, right? And then you would divide that by 2. Okay, so parentheses around that, divide that by 2, we get $53. Now we just want to make sure that it's accurate, so I get $52.50. That's important. We always want to look at rounding to the second decimal place in general. We don't really want to go to the 7th, 8th, 9th decimal place because those numbers, those fractions are just so small and so meaningless in most instances. But if we go to the second decimal place, to the pennies, that's good. So we're going to do the same thing over here. Okay, we're going to take the 75,000 plus the 90,000 and divide that by 2. Why do we divide it by 2? It's because we're dealing with two numbers, and we're just doing an average, right? We're doing the average of these two numbers. There's two numbers, divide it by 2. If we had 3 numbers, which we would not have in this type of a calculation, we wouldn't have this in price elasticity because we're only talking about 2 points. But we'd have a 3 if we were talking about multiple things. The point is, average would use the number of numbers that you're using. Okay? So here we get 82,500. Let's just bring that out to make sure. Yep, so we don't have any change. It's a solid, whole number there. So we're good to go. Okay? So that was step 1 and step 2. And it doesn't matter in this situation whether you do demand first or you do pricing first. Okay? One or the other, or flip it, it doesn't matter. What matters is when we get to step 5, you have to make sure that you have quantity demanded on top, and then price below that. That is what matters. You do that wrong, you've inverted the problem. You've gone left instead of right, you've gone up instead of down, you zigzag, and you're just not going to get the right numbers at all. Even if you get lucky, I won't award you points. Okay? So let's move to the next step here. We're going to do the percent change in price. Okay? And then I'm just going to write one over here, percent change demand. Okay? Just so that we can work with these numbers a little bit here. Just going to wrap text these things. And I'm going to put the calculation in here. So if you remember percent change using midpoint method, it's 45, so the new price, minus 60, the old price, okay, divided by the midpoint. Okay, this is why we did the midpoint in the first 2 steps, because we need to find a common denominator that would work whether we subtract 60 from 45 or 45 from 60. We still have that common denominator, and that is so important. Okay? So 52 over 50. That will give us a percent change of 0.285. So really, that's a percent change of about 29%. Okay? Next, we're going to do the same thing over here for demand. So we're going to do equals, and again, this is Excel, but I'm doing it as if you were able to write it on a sheet of paper. New demand is 90,000. Okay, spot check alert. Why is the new number higher than the old number in this situation? Okay, think about that for a moment. Okay, why do we have 90,000 demanded now? New is 90,000, old is 75,000. Whereas over by price, it was the other way. Can you think of why? It's the law of demand. When price goes up, quantity demanded goes down, or vice versa. When price goes down, as in this example, quantity demanded will increase. So we are seeing an increase here because we have a lower price. Okay, very good. That is one nice way to think about the problem, just to make sure you're doing it right, is does this problem fit with law of demand? My new price is lower, so I should expect my new quantity demanded to be higher, and vice versa. Okay? So we'll do that, and divide that by the 82,500, and we get 18%. Okay? Great, we did step 1, step 2, step 3, and step 4. Now what we need to do is price elasticity of demand. The big one. The main event is now here. Okay, so I'm just going to go further down because we don't need these numbers anymore. We just need to look at this set of numbers down here. Okay, so here's where we're going to go with this calculation. Remember that it's quantity over price. Okay, so Q over P. It's not P over Q. When they used to tell you that in English class, mind your P's and Q's. That's not what we're doing here. We're doing Q over P, QP. All right. So here we go. We're going to take that 18%, okay, divided by the 29%, okay? And we get this crazy number here, which we're just going to abbreviate down to here. The nearest whole number is fine, okay? So we get 62%. The other way to look at it is 0.62. Economists often like to look at it as decimals. Some people like to look at it as percentage, but ultimately it's really just a figure, right? Economists made this figure up, this price elasticity figure. What does 1 mean? What does greater than 1? What does less than 1 mean? We made it up. Now, we made it up because it makes sense and it's helpful in business, but this 62, 0.62 or 62%, it's the same thing. Depending on your audience, depending on how you use the information, how you prefer to see it, things like that. Now, I would like you to put it in 0.62 so that I can see that you're really looking at the numbers as a greater than 1 or less than 1 instead of 100%, because that's how you're going to evaluate it in this final step. Okay, so the final step here is this situation elastic or inelastic? Okay, so the rule of thumb is if it's less than 1, it is inelastic. It means there's not much sensitivity, right? If it equals 1, and Excel is not going to like me here, then it is unit elastic, which means for every change, there's an equal change. If I were to get 0.22 over 0.22, that would equal 1. So that means for every increase in price, there's an equal change in quantity. Okay? And then greater than 1 is elastic. So it is elastic. That means there's a lot of stretch. I raise my price by a little bit, I get a big change in demand. Okay? So let's look at this. Which one do you think this is? This number here. Which one do you think it is? Okay. So we're just looking at this number here. Which one? If you're thinking that it's inelastic, you are correct. Ding, ding. It is inelastic. It is less than 1. Okay? Now you might be thinking, but the demand went up. Okay? The demand went up. Why? Why is it inelastic if it conforms to the law of demand? There's a key thing here. Remember, the percent change, this 18%, in order for it to be inelastic, it has to be less than the percent change over here. Okay? Now, when we chop this up, so we would take the absolute reference of this, because we don't care about negatives here. We just want to know the magnitude of the change, the strength of the change. So we changed our price by almost 30%. Almost 30%. We almost cut our price by a third, almost. And we only got 18% change in quantity sold. So we changed our price by a greater amount than we actually received in quantity purchased. So we would say that that's inelastic. Now, for example, let's say that we changed our price by the 29% and we got 130,000 demanded. Okay? Our mid-point method is going to change. So instead of that 90,000, we would have 130. So now our midpoint's 102. And we would change our midpoint over here as well. So we'd adjust our formula just a little bit. So we would have new demand of 130,000 minus the original 75,000, but our midpoint also changed to 102,500. Now we have a percent change of 29%, about 30%, but our demand is 54%. Okay? So if we go down here and adjust our formula, still have our 29%, but now we're going to adjust for that 54%. We easily have 1.86. So if we go down here, 1.86, it's not this one, it's not this one, it's this one. We changed our price in this situation by a little bit, but our demand changed it by a lot. So those are the examples. That's what you'd be expected to say is, okay, not just that it's elastic, but that in this situation, our buyers are very sensitive to price swings. So that's very useful to the business as they think about pricing strategy, that they don't have to change it a lot. Because, for example, what if the sales goal was just to sell 90,000? Okay? What if the sales goal was to see what would happen if we changed it by 15%? Hypothetically, this would happen or that would happen. So that's how pricing managers study and use price elasticity. They get some sales data over a time period, and they just start moving the numbers around to study what the numbers would say. Okay? So hopefully this was helpful for you for the final and the rest of the course. Thank you.